Hey everyone, it's the Engineering Chicks. I'm Ashley and I'm here with Emily, and today we're going to go over another really quick problem. So the problem states 2 points A and B are selected randomly in the unit square and let D denote the distance between them. And then we had to use Monte Carlo to estimate the expected value of the distance between them and the variance. So here we're just randomly generating two sets of x's and y's, 5,000 iterations, running that through this formula here to get the average, the distance between the two sets of points. So this is just a distance formula. And then here it calculates the mean of the distance, then the variance, which is the standard deviation squared. So down here you can see that the expected distance between the points is 0.5206 and the variance is 0.0615. And then part B of the problem was just to graph the empirical distribution, which you can see right here. So part C of this problem was to suggest a more efficient method for estimating that the distance is greater than 1.4, and we knew that this probability would be very small, and so using Monte Carlo simulation it wouldn't work because you would have to run it, since the probability is so small, you would have to run it like a billion times to get any for it to actually happen once. And so we didn't have the time or capabilities really to do that because of what it would take on your computer. So we did it through finding the area of the triangle. We attempted this in MATLAB, but we were having just some issues with solving for the equation, so we decided to do it through like just through paper and through a graphing calculator. So we found the intersection of the circle and the square functions, and so that's like represented right here, and we found that that was this. I won't read it because the decimals are crazy, but then we used the distance formula, and using that we found the length of the base and the height of this triangle, and so then we were able to find the area. So we found that it was 0.000204. And then estimating the probability from this, so remember that we're basing this off of the unit square, and that area would be 1, and that the area of one triangle is 0.00204. So we multiplied that times 2 to represent the two areas that the points would have to fall into, so that the distance would be greater than 1.4. And so when we did that, we found that the probability of any given distance being greater than 1.4 is 4.1616 times 10 to the negative 8th. So definitely like a super small percentage in probability that D will actually be greater than 1.4.